New York City. Home to almost 8.4 million people, this beautiful city is where we wish the 2020 Biodesign Challenge could have been held. Like many large cities, New York City is filled to the brim with energy, excitement, and life. However, it is also plagued with the problems often correlated with urban areas: inequitable food access, severe lack of local food production, and high food insecurity rates. With 1.2 million individuals in New York City being food insecure, that is 12% higher than the national rate and 21% higher than New York State. This is Sam. He's decided to try his hand at a little food production. He lives in an apartment in Queens and wanted to grow some produce on his balcony. He figured, how hard can it be? Little water, dirt, sun, and soon enough plants will be there, right? Wrong. Growing produce is complicated, labor-intensive, and difficult. Creating a climate-appropriate growth matrix and balancing the various components of the soil often requires expertise beyond the average person. We want to change that. This is Cece, and she's holding a LIFEBRIK. Like Sam, she also wants to start growing some urban produce, but she is utilizing a much simpler tactic. That is, she is using LIFEBRIK. The layers of the brick all provide essential components of soil development. So, all Cece has to do is follow the provided instructions, and soon she'll be flexing her green thumb with ease. The importance of accessible urban agriculture cannot be overstated. It can play vital roles in supporting communities through social, environmental, public health, and economic facets. Adequate access to nutritious food can also directly affect the mental, social, and behavioral development of children and cannot be taken lightly when food should be a human right.
Thanks for watching. Let me introduce you to our team. I'm Cecilia Favorito, a freshman in design originally from Buffalo, New York. I love cycling, doing watercolors, making my own earrings, and going on hikes. I am passionate about conscious and human-centered design, and biodesign allows me the innovative space for these types of developments. LIFEBRIK grew from the roots of our team's interest in solving important, interconnected environmental problems.
Hi, my name is Manish Chidambaram, and I have just graduated with a degree in medical sciences and a minor in psychology. I'm a singer, adventure seeker, and seek to do my part in helping people. LIFEBRIK resonates with me because it is our chance to change the way food affects those with limited access to it. It lets us grow where, how, and what we want, and can be a game changer in more easily providing food.
Hi, I'm Sam, a recent graduate with a focus in medicine and nutrition. I play soccer and love all things outdoors. Through my experience working with nutrition deficiencies in urban areas, I've seen the direct impact that inequitable food access can have. By easing the process of urban agriculture, I believe LIFEBRIK can play a direct role in making our communities healthier and more sustainable. Our interdisciplinary team has been working diligently to create this solution, and we are so excited to introduce you to LIFEBRIK.
Our process in designing LIFEBRIK sought to follow a design thinking approach. We started by getting inspired. We also did an initial mind mapping exercise to start laying out some of our initial ideas for a solution to an environmental problem, or even just to understand the network of those environmental problems.
DC really wanted to focus on soil science, agriculture, potential fertilizer upgrades, and maybe even like working with compost, and then maybe even an urban environment. Hopes to capture and recycle nutrients and
We've really narrowed down the idea we want to move forward with.
Our collaborative brainstorms, individual research, and discussions with experts helped us narrow down our path of investigation.
It will reach for those nutrients, which is super important because then
a much more viable and larger topsoil to where now you can grow.
In order to get further, we dug in and made a couple of phone calls.
Yes, go ahead.
Hi, Professor Arnold.
Yes. Hi, Sam. This is Dave Knebel. How are you?
Hi, Professor Kupferly. Thank you so much for taking the time to talk with us today.
We learned a bit about their backgrounds and how they could help us with their expertise.
Are tasked with setting the vision, enabling our scientists to address agricultural problems using the best science
After explaining our concept, we got some feedback on how to improve from where we were.
Urban agriculture is taking off.
They asked questions that pointed us in new directions, expanding our perspectives on the project.
Is the matrix that you're selecting suitable for your crop growth? And that's another question we need to address is what crop do you see growing or what products? And is it going to be economically
They even suggested some new ideas that we ended up incorporating into our product.
the opportunities for, I don't know if you've read about these, but they're cover crops.
The experts also gave us direction on literature to further our studies of the soil science. We did lots of reading to solidify our direction.
It's actually empty spaces, the soil pores that are
And we all got together and watched Symphony of the Soils, which really gave us a whole new perspective of what it takes to create soil, how long it takes to create soil, and just the relative abundance of different, essentially, things that are part of the soil.
To define our goals, set timelines, and discuss our findings, we met bi-weekly. Before COVID-19, we were able to solidify our idea and even started planning for prototyping and model making.
This can't. Like, this is, like, totally chemically. I mean, that's so feasible, especially when you're talking about, like, the
Working remotely forced us to adapt to a new form of collaboration. We began to synthesize our ideas, validate our concepts through research, and brainstorm ways to best communicate our project. Through persevering, we were able to collaborate remotely and present you with LIFEBRIK.
Thanks, CC. Now that we've talked a little bit about our process, I want to talk to you about our concept and what exactly LIFEBRIK is. We wanted to create a soil source that retained all of the vital components of naturally occurring soil in a user-friendly way. To do so, we created a brick composed of 5 layers: mineral, carbon, profile, biota, and cover. Let's begin with the mineral layer. Naturally occurring soil often derives nutrients from its underlying geological material, referred to as parent material. We synthesize this with the granite and limestone matrix. This supplements the soil with nutrients such as calcium and phosphorus, and also acts as a buffer to maintain a neutral pH for optimum soil use. Like all of our layers, our mineral layer is comprised of recycled materials, primarily from restaurant and construction waste. Next up is the carbon layer, primarily composed as wood chips. As this layer breaks down over time, it will continue to provide long-form structure for the brick. In addition, it will also become a fertilizer source, decomposing into usable plant nutrition. Next is our profile layer. Comprised of sand, silt, and clay, we use an equal parts ratio to form a lush, loam layer. In addition, sediment diameter and surface area can be varied to determine porosity, water retention, and water drainage. This allows us to customize the optimal brick for varied climates. The soil is then inoculated with a mycorrhiza biota layer. These fungi form a symbiotic relationship with the crops. In exchange for simple sugars, mycorrhizae present water and mineral nutrients in a form plants can readily consume. Lastly is the cover layer. By utilizing the short life cycles of carbon sequestering legumes and wheatgrass, we work to strengthen the integrity of the soil, and the resulting decomposition works to catalyze the next batch of crop growth, upon which the customizable seed sheets, comprised of the desired produce starters, can be easily integrated into the soil system, and the consumer is well on their way to a flourishing urban garden.
As the current LIFEBRIK is geared towards urban farming in New York City, this product is expanding to include terroir, restaurants, education, and communities. The concept of terroir includes a set of farming practices and soil composition similar to that of the original soil where the crop is originally grown. This practice actively changes the phenotype of the crop and produces a more authentic taste. As restaurants would benefit from this and seek to provide the most fresh foods, and as we can benefit from certain restaurant wastes to be used towards specific layers of the brick, this mutual relationship will aid in their culinary gardens and our LIFEBRIK functionality. As child obesity and nutrition is of alarming concern, LIFEBRIK is an educational tool. It has also been found that garden environments have a positive impact on students who learn to increase fruit and vegetable intake and physical activity. LIFEBRIK is an opportunity for communities to come together through efforts for community gardens. These efforts bring community ties while increasing sustainability and food security in the poorest of neighborhoods. We are so excited to see LIFEBRIK continue to grow. If you have further questions or are interested in learning more, please check out our LIFEBRIK website.